Okay. I think we're gonna get started in a few minutes once we have a little more people join in. I think some people might be joining in a little bit late, so I'll wait like a couple minutes for those people to join in, and then we'll get started with our first presentation, which is going to be basically just the first part of an overview on how AWS works, Amazon Web Services, and like what goes into it, what's cloud computing in general, and a lot of stuff about that. And just a few things before we start. So as we go on, if you have any like questions while the presentation is happening, you can ask them in the Q&A, and I think like either me or someone else is going to be there to answer those questions. And then also, if you have any questions after the like presentation is over, there's going to be another option available for you to uh, there's gonna be another option maybe for the email like questions to me or to our HS Navigator team afterwards. So that if you have any questions about the slideshow, which we're also going to be sharing the slide in the recording, then you can feel free to ask us about that. And just for the rest of today, so this is going to go from 12 to 1, and then from 1 to 2 is going to be the presentation on Android app development, which Arch is going to give. Okay. And if you can't make any of the meetings, then there's going to be like the slideshows are going to be shared, and there's going to be recordings as well, so that you will make sure that you can always get the info that you want from the presentations that you want to attend. All right, I'm going to give it until around 12:04, 12:05 ish, just to see if any like class people want to join, and then we'll get started. All right. I think like other people can join in as we start. So I'm just gonna sort of get started with the presentation right now. So wait, just let me know. Are you guys able to see the screen? I want to make sure that like before I get started, like the slideshow is actually visible to everyone. Just let me know in the chat or anything. Okay. So the chat is visible to everyone. So I'll get started with the presentation. So today we're going to be going over just the first, starting like an overview of AWS, which is going to continue in the later weeks. And so let's get started. So there's just a little bit of background about me. So as I graduated from South Windsor High School, and I'm planning to go to Georgia Tech in the fall. and I'm going to study computer science, which is kind of why I wanted to start this program as well, so I could look into different technologies that I could experience when I go to college, or different things that I wanted to look up and search about. And I also have AWS certifications that I've done, like the certifications exams for them, and I've passed them. And so I had a little bit of experience with AWS in the past. And I've had experience with AWS in the past, and I've worked with some of the services there, along with like Oracle Cloud as well. So I'm just trying to say, like, teach some of the stuff that I've learned while just messing around with AWS and while preparing for some of these certification exams. And yeah, this is just a little bit more about me. If you guys are interested, I help teach at my local like temple, and I like traveling and cooking. It's just some of the things I like to do. Not so much traveling over quarantine, but a lot of cooking, because a lot of free time, a lot of banana bread, just like about everyone else has done. And I plan on going into computer science with but inside of computer science, a lot of people say that they want to go into computer science as like their future major, their future career, but there's a lot of different fields within computer science, like artificial intelligence, cybersecurity, astronomy, or just like theoretical computer science. So one of the things that we wanted to help do through this program was try to teach people that there's a lot more to computer science than what they think, and that you should not just like try to keep an open mind and try to see which fields or what you want to apply computer science to, instead of just spending your entire job just trying to look for like just theoretical coding. You can apply it to different fields like biology or cooking or architecture or anything that you want to do. And now we're going to get started going over what's the cloud and what is AWS. And just a disclaimer, this is sort of for educational purposes. Like, I try to make this information as accurate as possible, but it shouldn't be used as like the only material that you want. I think a lot of this is going to be a baseline for you to learn, and then from there you can go on and research on your own, and try to figure out new things, and use this as like a baseline for you to go on and explore the topics you're interested in the most. Okay. And so now, what is the cloud? Like, we always hear that, like, oh, the cloud's a new technology, or the cloud, they should put something on the cloud, like iCloud or anything like that. And so cloud computing is basically delivering like IT resources, like servers or databases or storage or applications, and delivering of those resources through through the internet. So basically, instead of having like physical servers and stuff that people run their applications on, they get those IT resources on demand, like as they need them, and pay as they go for the pricing. So instead of having to set up whole data centers, they can use someone else's data centers through the internet. And so the IT resources, like I said before, they include like compute power, like CPUs or those server racks, databases, storages, applications, and much more. And they let you sort of, instead of thinking of like your whatever application you're trying to run, instead of trying to worry about, oh, do I have enough servers to run this, or do I have enough like bandwidth or like Wi-Fi to run this, and you can just think, oh, I can use these resources through the internet and through the cloud is what it's called, to create my application and get it running. And so before like cloud computing, like hardware solutions are like physical. That means that they require you to have the hardware solutions require you to have the space, the staff, the security of the data centers. You have to have people run the data centers. People like keep track of, oh, is this data center running? Does this server get all the power that it needs? If there's a power failure, to keep track of it, and you have to guess like, oh, I think my application is going to need 100 servers, but it could actually need 50 servers, and you wasted the money on the 50 extra, or it can need 150, and you're running out of space. And if you need to change anything, then it requires time. You have to like wait for months for the service to be shipped in, or wait for weeks for a technician to come in and fix things. But in the cloud, everything's flexible. You can just buy as much as you need and use as much as you need. And once you don't need it anymore, you can just stop paying for it. It's much more flexible than without it. Okay. And so, like I said before, you don't have to guess what capacity you need. Like if you know that your server, if you don't know how many people are going to use your application, let's say you start a website and you put a movie trailer on it, you won't know how many people are going to look at that movie trailer before you put it out there. It could be 1,000 people. It could be 1 million people. And if you don't know, then you can't really buy enough servers to host that sort of demand. But with the cloud, then you can just have it buy as much as you need. So you can have it when there's 1,000 views, you can pay for only 1,000 views. When there's 1 million views, you can pay for the service for 1 million views. And so it's a really big advantage to use the cloud over using actual physical servers. And also another thing is without the without the need to like buy servers and buy physical hardware and wait for months for people to come in and fix it, or wait for people to be able to code everything to work with those servers, you can just go onto the cloud and deploy your resources within like minutes, instead of having minutes across the globe, without having to wait for physical servers or setting all that up and all the different like hassle that comes with that. Yeah, and just like I said before, like you don't have to spend money on running and maintaining data centers. You don't have to spend any money to get started, and you're able to go all the way across the world. Like have an application or website go from the U.S. to Japan to Russia in just seconds almost. And so there's different types of deployment within the cloud, and the different types are public, private, and hybrid are the main ones. So private cloud is kind of like your own data centers as well, where you host all the hardware, you host everything, you use like your on-premises stuff to host everything on the cloud. So it's basically the same thing as having a data center. Then there's hybrid cloud. Hybrid cloud is where you use some stuff from the data center and some resources from the cloud. So you use a little bit of both. And then the public cloud is some stuff like AWS or a Microsoft Azure cloud or Oracle's cloud or Google's cloud, which is where the resources are managed by those companies and anyone can go in and use them for their own private applications. And so the differences between public and private is public cloud, you don't have to pay anything to get started. You only have to pay for what you're using. While in the private cloud, you have to pay to set everything up first, and you have to pay for all the data centers and pay for everything else. And so the public cloud is a lot easier to use, a lot faster, and it's a lot more flexible in how many servers and how many things you can run on it. And so now we can talk about the different types of cloud service models, which I'll just show all of them first. So there's three of them. There's three main ones, which are SaaS, PaaS, and IaaS. And so SaaS is called software as a service, where you basically run everything on the cloud. Everything about your application runs on the cloud, whether it's the actual application itself, the data, the physical server racks that it's running on, the operating system, the storage, like how many gigabytes of storage that it needs, all the documents, all the data, everything is stored on the cloud. Like nothing, you don't have to worry about any of it. All the stuff is taken care of by the cloud. Then there's platform as a service, where you code your own application and have your own data, but you use the cloud as a platform to run everything. So all the hardware, all the server racks, all the operating system, everything is controlled by the cloud, but you keep track of your own application. So you manage your own application, just use the cloud as a platform to run it. And the third one is IaaS, which is infrastructure as a service, which is where you just use the hardware of the cloud. Everything else you take care of your own, whether it's like the operating system, the data, the actual application that you're making. All of that is done by yourself, but you're using the server racks that the cloud offers instead of having your own. So you're using this cloud's infrastructure to support your service. Then the next one is this is basically just another visual. So this is just another visual of cloud service models where you have infrastructure as a service, platform as a service, and software as a service. And it's sort of software as a service we have the most managed by the cloud, and infrastructure as a service is the least managed by the cloud and the most managed by yourself. And so just to give you an idea, the biggest cloud vendors like today at least are AWS is the biggest one with around 32% of the market in the cloud is done by AWS, which is and it's a really big market, $130 billion. The next one is Microsoft, the Azure, and then there's Google, Alibaba, IBM, and all the rest who make up a lot less percentage. But AWS is a really big one, and it has the most services as well within it. So that's kind of why I'm trying to teach you the generals of cloud, but also mainly through AWS, since that's the one you're probably going to be the most exposed to in the actual industry. And so throughout the presentation, there's going to be a lot of these different links. And so these links, the reason I'm giving these links in the slideshow and not actually playing them is because there's a lot of this is going to be hard to visualize just from the slideshow, but since we're giving you this presentation, we have videos included in them that give you a lot more in detail and a lot more like it's a lot easier to learn from videos as well because they have like visual representations and they have someone else explaining just those specific details. So if there's anything you have questions about, you can either look at the slides and look at the videos as well because most of them are taught by actual like people who work for Amazon, so they're able to teach you in a lot more detail and a lot easier on a lot of the different topics about cloud computing and the specific services that we're going to be going over. So now, what is AWS? AWS stands for Amazon Web Services, which is basically just a web service, is just a fancy way of saying any software that makes itself over the web. It's any software that's over the internet, and it uses like standardized formats like JSON for different requests that it makes across the internet between your application and the Amazon Web Services. And it's a platform for the cloud, which has over 165 different services available, which is a lot of different things you can do. There's almost anything you can do with the cloud, and anything that you need to do with your application, it's almost guaranteed that's going to be available on Amazon Web Services. And this is just some more stuff about AWS. So what is AWS? And I'm actually going to click on this link just to give you an idea. So you can actually create a free AWS account. So AWS doesn't cost money. And I can show you here. Um, okay, one second. Let me see if I can drag this over to this screen.
Hi, my name is Jenny, and I'm looking for customer software purchase. AWS.amazon.com.
So AWS has their website where you can sign in, and they have what's called a free tier. This video is going to be in the presentation, so I'm not going to go through the entire video, but I just want to show you. So on the AWS website, you can create an Amazon account, an AWS account, which is different from like an Amazon, like just like a shopping account, and you're able to actually do a lot of that stuff. Actually, everything that we were talking about in this presentation, you're able to run for free on Amazon Web Services because of their free tier. So for a year after you make your account, you can actually go on there, play around with these different platforms, play around with these different services, and make things that interest you for free because Amazon provides this free tier for you. And so you're not like limited by like having to pay money for like doing a lot of the experimentation with this presentation. You can actually go in and play around with the cloud for yourself and actually experience what it is, what it's like to work with the cloud firsthand. Okay, let me continue on with the slideshow. Let me pull it up one second. Okay, so one of the high level ideas within AWS are the idea of regions, which are basically geographical areas that Amazon lets you launch instances of software that they create. And so you can launch like your softwares, your EC2 instances, your instances in the region that gives you the that gives you the least latency, the lowest costs, or like regulatory requirements. So let's say we live in New Jersey, right? So the region that we would probably want to give our sort of platform, our services for, and the region that we want to deploy our things in, probably be the U.S. East region. Like there's like a U.S. East region in Amazon. We probably want to put our programs in the U.S. East region so that they have the least latency for us. But let's say you're a software developer in Europe, and Europe has certain copyright restrictions. Then you could say that for an application that you have hosted in the US, you would have to have the region that you deploy your instances in Europe, so that despite the fact that you're in the US, you can abide by the copyright restrictions that the UK has by putting your EC2 instances inside that region. And within each region, there's multiple of what's called availability zones. So availability zones are basically data centers inside the regions that are designed to be like isolated from faults. So if you have, let's say, the US East region, Amazon didn't want to make it so that there's only one data center in each region, because then if there's only one data center, if that data center went down, then that entire region went down. So if you if you have like, so let's say you have the U.S. East region, then within the U.S. East region, there's like multiple availability zones within that region, like one in, let's say, Virginia, or one in the New Jersey. I'm not sure actually where the specific regions are in the U.S. East, but there's multiple of them, so that even if one data center goes down, then the rest are there to support all the applications that take place in the U.S. East region, so that and make sure that no matter what, your application stays standing and is able to withstand like any power failures or natural disasters or anything like that. And here's another demonstration that goes over some of the high level stuff that I was talking about. And you're going to see in these next few slides, Amazon has a lot of core services. We're not going to go over all of these or even near all of these, but Amazon has a lot. Like this is all their stuff they have for databases, storage, networking, compute. And they have even more for Internet of Things, for mobile services, for enterprise apps, analytics. And then there's still even more for app security management and developer tools. There's a lot of services that Amazon has. And we're going to be covering some of the main free ones that are available, and just going over like some of them in detail and some of them at a high level, just to like give you an introduction to some of the many, 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 many services that Amazon Web Services offers. So the way that so you might be wondering, okay, so I know that Amazon Web Services is a cloud, and I know that there's a lot of things available for Amazon Web Service that I can do, but how do I actually access Amazon Web Services? And the way that you access AWS is through the AWS Management Console. Then there's also a command line interface, and there's a software development kit. So you can either code your way through Amazon Web Services, use a command prompt to access Amazon Web Services, or they have an online console to do it for you. Okay. And for a little bit of background, Amazon Web Services has grown a lot throughout the years. Um, they didn't always have like all the 165 like services that they offer now. They started off really small, and then they grew and grew and grew and grew into where they are today. So at the beginning, they just had a basic way to store things called S3 and EC2. So they gave you storage and they gave you servers. That was where it started off, and that's where the idea started off. And then the more and more people that decided to use it, the more and more services they began to offer, like relational databases or private networks. And then they added more databases. They had the ability to use IP addresses, the ability to create domains and create websites on the platform. They added even more databases, even different ways of like managing your databases, and then certification so that people could actually get jobs and prove that they have proficiency in Amazon Web Services, because a lot of companies need people who have skills in this area because they're moving all their infrastructure over towards it. And so the first idea that we're going to be going over is Amazon Web Services storage, or like the basics of Amazon Web Services storage. So within storage, there's so within storage, some of the main concepts within the storage is Amazon S3 and Amazon Glacier, which I'll go over now. So what is Amazon S3? S3 stands for Simple Storage Service. The three S's, S3. Yeah. And it's, let me show all these first. It's basically a highly secure and a highly scalable way to store objects, store files, and it's object based storage. It's not like storage like a database. It's kind of storage like the way your hard drive has storage. You can store files on there, and the files can be anywhere from 0 bytes to all the way up to 5 terabyte files. And there's unlimited storage of the cloud as long as you're able to pay for the stuff that you store, and it's easy. It's really easy to use, and it's almost as easy to use as like your normal hard drive in the way you store stuff on the cloud, except it doesn't take up any physical space on your computer. It takes up space on Amazon's computers, Amazon data centers, and you're able to access any amount of data, like put up any amount of data to the cloud, and access that from anywhere else on the web and anywhere across the world as well. And it's always available and durable. You're going to hear a lot, and that basically means that even if there's faults within data centers or within Amazon's data centers, that your files are always going to be there for you to access, and they're redundant, and so they sustain that in the case of any sort of power outage or anything. You can always make sure that you can access your files, and they're always going to be your files, and they're always not going to have any corruption within them. And so the way the S3 stores things is like the way that your computer has, like Windows or Mac, your computer has folders. And instead of folders on S3, they have what's called buckets. And the buckets can store files and items from 0 bytes to 5 terabytes, like I said before. And the Amazon Web Services buckets are also unique in the name that they show up. So since everything is served over the internet, then as you see at the bottom, there's a URL that comes up. And you've probably actually seen this URL before when you were just browsing the web. A lot of websites use S3 for the services, so you might have seen a URL that looks kind of like this. But basically, the first thing before the s3.amazonaws.com is the bucket name. And each bucket name is unique. Like no two things under the same bucket name. So if I make a bucket called school homework files and I put my school homework files in there, then no one else can make a bucket called school homework files. Otherwise, it would overwrite my bucket. So they can't do that. Every bucket name has to be unique. And then you're also able to access the different objects and files within them. And since it's access to the internet, you can use code to upload files. You can upload files manually to the web console, or you can use a command line as well. And since it's served on the internet, once you successfully upload something to there, you get an HTTP 200 code, which is success code. And so the way that you can use Amazon S3 is one, for a backup. So if you want to upload backups, since they're static files, they're not going to change, like backups don't really change, then you can upload your backups to Amazon S3. You can archive information, like archive files on S3. You can use it for disaster recovery, like always have a copy of your files uploaded onto S3 so that if one of your services ever goes down, you can get a disaster recovery from it. You can cache things, and you can actually host simple websites directly from Amazon Web Services and S3. Like you can use just S3 and host a website of your own. And like I said before, this is kind of reiterating what I said before, but the user uploads and downloads an object to the internet as an Amazon S3 bucket, and the bucket has to be a unique namespace. And once they upload it to S3, then they're able to access it from an HTTP URL, like the one I showed before. So now I'm going to go into some of the different storage classes that S3 has to offer. So the first one is the standard S3. It's just the standard, like you upload it into a bucket and you're able to access that information whenever you want and upload it to whenever you want without having to pay for anything more than the storage. And it's used for basically just hosting static websites or uploading random files to the cloud or analyzing large amounts of data. Then there's also standard infrequent access. So standard infrequent access is for data that you're gonna infrequently access. And so the reason it's a different tier is because the way they charge you for infrequent access is they charge you more for accessing the data, but it costs less to store it. So it's used for like backups and archives where it's like files you're not going to access all that much. You're only going to access them one time in the case of emergency, or for like long retained data or disaster recovery. And then there's Amazon Glacier, which is long-term archives, like preservation, like stuff like museums and stuff like that would use like Amazon Glacier for preserving files over long periods of time. And you're preserving them digitally as well. So it costs a lot less than a normal standard S3, but you're not able to access your files easily, and mainly just for seeing them visibly after a long period of time. And so on the bottom, you can see it's like more active data. Active data you're going to keep changing and uploading. You should put in standard, and the less frequently you access it, the more it should go towards like the archive of like Amazon Glacier. Let's just actually. Okay. So now we have what's called data collection. So a lot of companies um, sort of establish themselves, or a lot of like businesses establish themselves before Amazon Web Services was a thing, or they didn't start themselves out on the cloud. And you might be wondering, well, how do they actually get their data onto the cloud? Because if they want to move to the cloud, it's going to be hard to transfer like servers upon servers of data and terabytes of data to the cloud. So the way they do that is through something called Snowball and Snowmobile. So an Amazon Snowball is like an actual, like that's a picture of like an actual Amazon Snowball. And what they do is they connect that Snowball to one of their like real like data centers in person, and they copy the data from that server to the Snowball. And then Amazon takes that Snowball and uploads it into the cloud for them, so that all their like up to 80 terabytes of data is stored within the cloud through that Snowball. But some companies have a lot of data, like a lot more than 80 terabytes. They have like petabytes of data. And for those companies, there's an actual truck called an Amazon Snowmobile, which comes in and comes to the data center and uploads up to 100 petabytes of data into that Snowmobile, and then takes that truck back to an Amazon data center and uploads that to the cloud as well. So they're able to upload really, really large amounts of information, really large applications to the cloud through using one of Amazon's like real life in-person services as well. Okay, so now to go into some of the information about um, how S3 actually like works. So S3 has, like I said before, there's buckets, and buckets are containers or like folders for the objects that you store in S3. So once you have like a folder made, which is called a bucket, you can upload any number of objects, whether it's like pictures, documents, HTML files, code files. You can upload all that to the bucket, and it just stores it. And but the thing is that Amazon S3 bucket names, since they're URLs and since they're like served over the internet, the names have to be globally unique, and they have to be created in the region that you specify. So like just like someone else, like since Google already owns a domain name google.com, no one else can make a website and have it set to google.com. So in the same way, if someone has a bucket called school homework files, then no one else can now have the a bucket named school homework files, because then both of them will point towards the same URL, and that would overwrite things. So each one of the names of your buckets has to be globally unique, kind of like a username when you're making a new account or something. And like I said before, uh, the way that you choose regions is to minimize latency, costs, and adjust regulatory requirements. I think Spotify is a pretty good example of this for regulatory requirements too, because um, certain songs in Spotify are copyright restricted to the countries that they come from. Like some songs from England or some songs from like Korea or some songs from like Japan might be like region locked to that specific country, and you're not supposed to be able to, and they don't have copyright access to access them in the U.S. So like Spotify would deploy certain certain S3 buckets or certain servers within regions to abide by the copyright restrictions and make sure that other countries can't access them because they're unique from each other. And then you can also create up to 100 buckets for each of your AWS account. Each one of the buckets can store an infinite amount of objects, up to 5 terabytes per. And you can also delete the buckets when they're not in use. So that's way like you don't run out of like we don't run out of the namespace because you can just delete the bucket and reuse that bucket name for anything that you want. So you can delete your school homework files but still keep that URL and use it for something else. And you can also make it publicly accessible. So if you don't want your thing to be private, you can also have your bucket open to the web and anyone can access your bucket and the files within it. And like I said before, with this, with the ability to make buckets, you can host static websites on Amazon S3. And what I mean by static websites is like websites that don't have changing content. So if you, let's say, you just want a website that hosts a movie trailer, like it doesn't change anything, there's no like changing counters. It just has like a movie trailer playing with like a fancy background on it. You can host that through S3, and you can just host the movie file and the HTML file right there in S3 and be able to host a static website for there. And the reason that you would want to do that is because it comes at a low cost and it's highly available and it scales to meet demand. So whether you have like I said, 1,000 people, 1,000,000 people, 1,000,000,000 people watching it, it would the S3 static website is able to scale to is able to scale automatically to meet demands. Yeah. So like I'm able I my website's called hsnavigator.org, but I can also host like a static version of my website on S3 and have that posted up just as like a backup for my current website if my website ever goes down. And then there's another thing in S3. Like S3 has a lot of different features, as you can see. So another one of the features that Amazon S3 offers is the ability to do what's called cross-region replication, which is kind of exactly what it sounds like. You're able to have, let's say I make a bucket, since you make buckets per region, I make a bucket here in the US East region, since I'm on the East Coast. And I want to have that region available all the way in, let's say, the Russia region. And I want to have my files available to one of my colleagues who lives in Russia, who fits in the Russia region, the Russian availability zone. So what I can do is I can enable something called cross-region replication, which means that whatever files I upload to my Amazon S3 bucket, it's available to the person in the Russia region as well, and they're able to access the same files as I'm accessing, and they're able to see the changes that I make in their S3 bucket and they're able to access my S3 bucket and access those same things and also get the same data that I'm getting. So it's a nice way of like replicating objects across different regions since S3 is only for one. And then there's something called CloudFront. So CloudFront is it's a CDN. It's called a Cloud Content Delivery Network, which sounds kind of complicated, but it's not as complicated as it sounds or it looks. So basically, um, what CloudFront is, and I think a good example of this might be like something like Netflix or something to show what S3 does. So what CloudFront does is it caches copies of content close to end users, and so it lowers latencies when they download or stream the objects. So let's say there's a central like Netflix server in like in Europe. Let's say there's a central like Netflix server in Europe, and that's where content is hosted. And I'm over here in New Jersey, and I access that file. So if I access that file, then it's going to take a while for me to get that information from Europe to my end on the East Coast. But then if they use CloudFront, then once I download that information, then instead of the information going straight from the Europe data center to my laptop, it'll go from the Europe data center and download it to the edge location near me, and it's going to be stored at the edge location. And then I can access that information. And then if someone else, let's say my neighbor, wants to access that same information, then they don't have to wait for the information to come all the way from Europe to me, to them. They can just access it from the edge location near me and get it a lot faster. So they're able to cache contents of the copies, especially if a lot of people want to watch just one show. Then instead of each person have to wait for the information to travel from Europe to the East Coast, then one person can wait for that and have it, and it comes to the CloudFront network, and then everyone's able to access it a lot quicker, and access cache copies of that content. So it's sort of like the best way I can see to explain how this CloudFront works. And it takes a lot of load off the web servers, it reduces cost, and it makes your services a lot faster and a lot more reliable, because people are getting content a lot quicker, and it ensures that replicas of the content are always available. And it's just a better user experience because they don't have to wait as long. They're able to get the information they need a lot quicker. This is just a little bit more about how CloudFront works, but basically, it's just there's a S3 bucket, or there's an origin with the content. Then if the content isn't cached, then a cache just means it's like stored. So if the object is not stored, then the edge location requests it from the original bucket. Let's say the Europe Netflix server that has all the shows on it, and requests that from the server, and it stores it at that edge location, which is, as you see here, this sort of blue area is the edge location. So we request to watch a show, and it goes over, the request travels through the edge location to the Netflix Europe server, and that sends it to the edge location, and then we get it from there. So it takes a little bit for the first user to get it, but then the next user, instead of having to go all the way to the Europe server and then all the way back, they can just call that an edge location and get the information back in half the steps. And so it's able to get a lot of people get that information a lot quicker. And it's not just Netflix. Netflix is just an example it's using. It can be used for anything, or any number of services or applications can use CloudFront. And now we're going to talk about how S3 sort of protects data from mess ups, or from sort of deletes or accidental deletes or accidental failures that you have within the information you put up. So there's something called versioning, which is kind of like, if people here have used like GitHub before, it's kind of like that, where every time you upload something to the bucket, then it sets like a new version of like a new version that it saves. And if, let's say, you messed up something on a feature like upload, you can roll back to a previous save that you made. So if you uploaded a file once and it's correct, you upload it again and it's correct, but the third time you upload it, you mess something up, you can roll back to the second version instead of having to delete everything all over again, which helps you with it basically helps you with keeping hold on one second, keeping all of your information like protected from versioning. So the next type of protection they offer is something called protection on delete, which basically means that it requires multiple forms of authentication. Hold on, the slideshow just closed. Okay, so it provides multiple levels of authentication needed to make one delete. One second, something's coming up. Yeah, so it requires multiple people to authenticate when you're deleting a bucket, or to change the version you save your bucket, so that you can't just accidentally press delete. You have to go through multiple steps and make sure that you really want to delete or really want to make a version change to your file. And then the next thing we're talking about is something called lifecycle management, um, which kind of like fits into the next thing with versioning. So lifecycle management is basically when you change the data that you have to different life cycles or different types of S3 as you go along. So let's say, I think the next slide explains it the best. So let's say you have data that you're not going to access as much, or that data that changes on how you're going to access it. So you shouldn't always store it in standard, because that's going to cost a lot more than storing it in Glacier or storing it in standard and frequent access. So let's say you have a file and you keep it in standard originally. But if someone doesn't access that file in 90 days, you can transition that file to infrequently access. So it costs less, and if you're not accessing it, then what's the point of paying for the full S3? And then if no one accesses it after a whole year, then why keep it in standard and frequent access? We can just move it to Glacier and archive it, because then you know no one's going to access it. So then you can just keep on moving it further and further, like lower costs and to longer term storage and archive storage instead of active storage. And the bottom, instead of just having it move to different types of storage, you can just make it so that after 1 year, if no one accesses it, it just deletes it. So it doesn't like take up S3 space and cost more money. You can just have it delete automatically if it's not being used. So now we can look at the different sort of pricing that S3 has, and like what I was saying before, where the normal S3 costs around 0.023 like dollars per gigabyte, or around 0.020 dollars per gigabyte. But if you want to do lifecycle management, you save a lot of money, because let's say you move it to infrequently access, then you only cost 0.0125 dollars per gigabyte. And if you move it to archive data, then it costs only like 0.004 dollars per gigabyte. So you can see it's a drastic price difference. And if you're not going to access the data, you might as well do the lifecycle and move it further and further on as you're going along. And so another thing that's important about data storage, or like storing data in general, not just in Amazon Web Services, is encryption. And S3 also provides the ability to do encryption on your data. So you can, and the way S3 encrypts data is by securing it in transit. So as you upload the data, it encrypts it, or you can have it that encrypts it upon like you upload it and then it encrypts it there, or it encrypts it before you upload it. So you can do all three of those different options, which is just based on your use case. And it can automatically encrypt your data on writing it and decrypt it on retrieval. So you don't have to worry about encrypting or decrypting on your end. Amazon can just handle all of that. And so the server side encryption, which basically means the encryption that Amazon handles, or like through stuff like S3 managed keys. They have a key management service. They have like customer provided keys. So, like if you don't want to use keys that Amazon creates, but you have like your own company policy keys, and you can use those. And there's a bunch of different options that for Amazon to encrypt your data, so that you don't have to worry about encryption. It just, you upload the file, it's encrypted automatically, and you take the file out and it's decrypted automatically. But like always, there's companies that sort of don't like that policy or want the ability to store the encryption for their own. So then they just go do what's called client-side encryption. Yeah, and I think this sort of visual shows. I think this visual shows like some of the basics of how it works. That a client through the internet uploads their data, and they give a key, and Amazon goes through whatever encryption algorithm it wants and puts it on S3. And the reverse happens when it goes back. It goes through a decryption algorithm, and it sends the object data back to the client. And so with S3, there's, if you store a lot of data on S3, then there's obviously ways you want to be able to query your data. And query just means like search your data. You want to be able to search your data easily. And one of the ways you can search your data easily is called Amazon Athena, which lets you make SQL queries on your S3 data. And SQL we'll go over tomorrow about what SQL actually is. But basically, it's a way of searching your data easily and finding different individual characteristics of your data. And Amazon Athena lets you like search for your data on S3, and it supports like column formats and like returns data in like CSV or JSON formats. And it's a really convenient way for companies or for people like you to who store a lot of data on S3 to search your data and get that data back in a way that not only you can read but also computers can read as well. And then another part of S3, like these are just features of S3, and they're not like big parts of it, but there's things you can do with S3. So let's say you have a really really big file, and since Amazon S3 only provides up to 5 GB per put operation, which is per upload operation, you can have like let's say a file that's 1 GB, you can split it up into multiple 5 MB uploads, and then upload all those files, all those 5 MB files only take a little bit amount of time to do. And if you run them all parallel or all like at the same time, you can upload a 1 GB file a lot quicker than just trying to upload the entire 1 GB at once. And then there's also S3 server access logging, which tracks like requests to your bucket. So companies sometimes want to like see how many people are using their S3 buckets or who have access to which bucket. So you can do something called server access logging, which logs like, okay, who's calling this server, who's calling this bucket, who's calling this folder, who's taking this file out, what's that file called, like how much time did it take them to take that file out, because people want their information as quick as possible. So if companies see that this bucket takes like 20 seconds, this bucket takes like 1 second to upload the data to take it out, while this bucket takes half a second, why is that bucket taking a longer time? And also like any responses or errors that come up as well. And it can also help like you if you're working on S3. If you set up server access logging, then it can help you see like where's your money going, how is your storage being used, and how can you use it sort of more efficiently if you want to. And I think the final slide that we have is what are some of the customers of S3? How is S3 used in the real world? So, like I said before, we have Netflix delivers hours of content, like billions of hours of content from Amazon S3 every single day. And then there's a company like SmugMug who stores billions of photos and images on S3. There's SoundCloud, which currently stores 2.5 petabytes of data on Amazon Glacier. So it archives all that music that's uploaded on Amazon Glacier. And then there's Airbnb, which handles over 10 petabytes of user images on the Amazon S3. So they're able to access like images of like their houses or images of like the rentals that they're offering. And then there's NASDAQ, which stores years of historical ticker data down to the millisecond on Amazon S3. So it's a lot of like big companies, a lot of big like um, organizations use S3 to store their data. It's not just used for smaller companies. And this slideshow is going to be shared with you, so you're able to see all the different information that S3 offers and a lot of these new live demos as well. And I think with that, that's going to conclude today's like part one of Amazon Web Services. Basically, just all about S3, which is one of the biggest services that Amazon Web Services offer. And I think that's almost time for us as well, since we're going to be transitioning to the next presentation with Arsh teaching us about intro to app development. So if you guys have any like last questions, you can send them in the chat, and then you can move over to the other webinar for working with Arsh on learning Android app development. Okay, if there's no final questions, I'm going to stop the recording, stop the webinar here, and you guys can move over to the next one. Thank you, and I'll see you tomorrow at 12 o'clock again for the presentation on SQL. Have a nice day.